Welcome everyone, welcome to the Smart Interviews YouTube channel. Today we are going to discuss problems from Codechef Starters 131. Okay, so we are going to start with the first problem. And first problem that is we are going to discuss is got to catch 'em all. So we are playing we are playing our favorite video game Pokemon, and our objective is of course to catch them all. So in this game, there are n different Pokemon, and the ith Pokemon has a difficulty of A of I to catch it. Okay, and to catch this Pokemon, we need to use Pokeballs, and it is given that a normal type of Pokeball costs us X units, whereas a Master Ball costs us Y unit. Okay, so those are the costs of the Pokeballs. And let's say if A of I is the difficulty to catch ith Pokemon, A of I is the difficulty to catch ith Pokemon, then we need A of I normal balls to catch it. Okay, so we need A of I normal balls, normal Pokeballs to catch it. Okay, and in case of Master Ball, you need only one Master Ball to catch any Pokemon. Okay, so that is the information provided to us in the question, and we are asked to find the minimum number of coins required to catch all Pokemon. Okay, minimum number of cost to buy Pokeballs so that we can catch all Pokemons that we have. And if we look at the output format, uh, it is something like this. Let's if you look at the input format first, we are given t test cases, and after that n xy cost of picovolts and the picomon or the difficulty to catch each picomon. Let's try to understand one of the examples here. So our array size is 4, so n is 4. Let's go with the first example. Array size is 4, and the cost of normal pokeball is 5, and the cost of master ball is 30. Now we need the minimum cost to catch each pokemon, right? Let's pokemon, sorry. This is our array. So if you want to find out the minimum cost to catch each pokemon, what are first of all, what are our options to catch a pokemon? You can either catch it with a normal ball, or you can catch it with a master ball, right? So to get the minimum sum for each Pokemon, it is better for us to find how much it costs to catch a Pokemon with normal ball, and how much it costs to catch it with a Master Ball, and we'll just take the minimum of those. Right. So going with that, for first Pokemon, if I use a normal ball, I need to use 4 normal balls to catch it because difficulty is 4. So 4 normal balls and each costing 5 units, so 20. Whereas a master ball, I can catch it using a single master ball, so it is going to cost 30 units. Coming to the next Pokemon, it will be 5 into 5, that is 25 coins for catching it with a normal ball, and 30 coins for catching it with a master ball. Okay, similarly this will take 10 units or 10 coins for a normal to catch it with normal balls, and same 30 for master ball. And here 15 units with 15 coins with normal ball and 30 coins with master ball. So if you want to find the minimum cost, it is simply picking the minimum in every case, right? So that would give us the optimal answer. So it would be just 20 plus 25 plus 10 plus 15. So that would give us the answer of 70. So this is the main logic here. At every Pokemon, we have to just find out how much does it cost. Let's try to implement the logic and see how it will go. So yeah, we'll try to we'll code this the logic that we just discussed. So first, input format says that we have t test cases. So I'll just run a loop for t times. So I'll just run it like this. So it will directly take the input and run a for loop for those many iterations. Next, in the next line, we are given three values: n comma x and y. N is the size, X and Y are the costs of normal and master pickleball. So we'll take the input of that too. Okay, we got the input of that. Next, we have our array. So that is called difficulty to catch each Pokemon. So we'll take the input of that too. And we'll declare our answer variable. Answer is 0. And we'll iterate through the array. Sorry, iterate through the array for I in range of n. Now, what was our logic? We will add the minimum value to the answer. Minimum of what? Minimum of catching the Pokemon with normal mode. That would be just L of I, the difficulty, into number of the cost of each normal one. So L of I into X, and catching it with a normal one. So y. So these two are the costs. So we have to pick minimum of them. So we'll just write it as minimum of these two, and we'll just print our answer. So let's run this. Okay. Yeah, let's run this. Okay, we successfully executed the solution and it is matching with our output. Let's submit this. So yeah, as you can see, we have successfully solved this question. Let's move on to the next question. Okay, let's discuss the next question. And this question is called as dice deception. Okay, so Alice and Bob are playing a board game and they must roll a standard six face dice n times. Okay, and their actions, okay, the sum of the values that they get decides who is going to be the winner. And on now let's talking about the question. Alice rolls the dice and obtains a sequence, and let's call it A1, A2, and so on up to AN. Okay, that those are the values she got when she tossed the die and rolls the die. And however, if you see, Bob is not actually paying attention on how much Alice is rolling. So Alice decides to cheat. And so, what? How she can cheat? She can choose the die and flip it to the opposite side of the face, and so that the sum of the values of the opposite side plus the current side is equal to 7. That is, if she rolled 1, she can transform it to 6 or flip it to 6, roll 2, flip it to 5, and roll 3, flip it to 4. Okay, that is the cheating that she can know. And so that Bob does not, get any suspicion. She can do it at most k times. Now, if Alice is going to do this, what is the maximum score that she can obtain? Okay, we have our input format. Let's try to look at them first. So we have t test cases, and next line has n comma k, and the values that Alice has thrown. Okay, and we have to print the maximum profit that she can get. Let's look at the example ones. So 3 comma 4. So 3 can be converted to here. 3 comma 4 is are the roles that Alice has done. So 3 comma 4 here, to get the maximum sum, we can simply, what is our simple task is, we can convert 3 into 4. So our value will be 4 plus 4. So 8 is going to be the answer in this case. So like this, when we move on to the next one, it is better for us to convert 3 into 4 so that the value will increase. So 4 plus, so we will have one chance left, and we have next 4. If we flip it, the value will reduce. We want the maximum score, so we will not flip it, and 4 will not flip it. 5, it is going to be the same. So the maximum score obtainable is simply sum of all this, so 17. Like this, we have to perform our flips. Next, this array that we have, 1 2 3 2 1. So let's say we are and we can have 3 flips. Let's say we are linearly moving and trying to flip. So 1 will become 6, 2 will become 5, and 3 will become 4. So the output in this case is 10, 15, and 18. But our output is 22. So if we look here, we can flip any values, right? We can flip any values in the array, and to get the maximum answer, any values which are less than 3 to increase the value less than or equal to 3. But to get the maximum answer, it is better for us to flip the lower values first. Like if we have 1 1 and 2, and we have, let's say we have 1 2 and 1, 1 2 1, and we can make 2 flips. It is better for us to go with flipping all ones first, so that these ones make 6, right? These ones are going to be turned as 6, whereas if you flip 2 instead, it will just be a 5. So these ones are going to give us more score compared than flipping 2, which is going to give us 5, right? So in this case, instead of linearly flipping, the better option for us is to flip all ones first. So this will become 6, this will become 6, and one more chance is left. So instead of flipping 3, we'll flip with the next smallest number, that is 2. So we'll have 5. With this, our output will be so 3 is as it is. So in this case, our output will be 22, right? So that is our main logic, and using that we can find out our answer. So all we need to do is to easily count, like flip ones first. What we can simply do is, first we can sort this array. So 1 2 3 2 1 becomes 1 1 2 2 3, and every time we see any values between 1 2 and 3, we'll just flip them and add it to our answer. Okay, now we can just flip them and add it to our answer, and we'll do it at most k times and break our loop. So that is going to be the logic for solving this question. Let's try to implement it. Okay, let's try to code this up. First, we'll run a loop for t times. Okay, next we'll take the input of n and k. So n comma k is map of input. Next we have our array. So list. Okay, now since we have to pick the minimum first, we'll sort the array, and now we'll run a loop. We'll just iterate through the array. Now if I is less than or equals to 3, then we can flip it, but we can flip it at most k times. So I'll also write a condition that k should be greater than, less than, sorry, greater than 0. If that is the case, what I'll do is I'll just change the value of I to 7 minus I, that is, I'll flip it. Here I'll also decrement the value of k by 1, and after that we'll just add this value of I here, and we'll print answer. So with the above loop, if I is less than 3 and less than or equal to 3 and k is greater than 0, then we'll flip it and add it, or else if those conditions are not true, we'll just directly add the value to the answer. So let's run this. So we did not declare the answer, so let's just declare answer as 0. Yeah, so let's submit this one. Yeah, we got our answer. We submitted our answer. So let's move on to the next problem from here. Okay, guys, let's start with the next question. So this question is called as k closeness, and here we are given an array and one more integer value k, and we can perform the following operation on any array element. That is, we can pick any element from the array, and we can add the value of I to it. Okay, sorry, k to it. So we can update like this. So if we can perform this operation, what is the minimum possible value of maximum of A and minimum of A attainable? If we can perform operations, how many times we like? It can be 0, it can be more than that. What is the minimum possible value that you can get by performing max of A minus min of A? That is the question. Okay, and we have our input and output formats here. Now let's try to understand a few examples. So here we are given the array as 1, 5 and 4. So and the value of k equals to 4. That is, we can update any array element by 4. So the question says that if we now currently if we take minimum minus maximum, it is 5 minus 1, which is equals to 4. Now here if we update 1 to 4, update once, and that is add 4 to it, our new array will be 554. In this case, minimum minus maximum is 1, and whatever we do, 1 is going to be the option. Whatever value we update, let's say we update this with 5, sorry, add with 4. So in this case, we'll get a value of 8 minus 5, 3. So whatever we do, this is the best possible answer that we can get. So that is the question, and how we can do it. Now if we look at, let's try to solve this question. At first we will look at this example and try to understand how can we solve this. Now our example is 1 2 4, 128, 130 and 131. 128, 130 and 131. If we look at these things, these are in very various ranges, right? If 1 is starting from here, 2 is here, 4 is here, 128 is somewhere here in our number line. If we try to draw a graph, this is the value we are going to get, and we are also given that k is equals to 12, right? So since we can increase any value by k, since we can increase any value by k, what we can do is we can add some multiple of k to this one, so that it reaches somewhat close to it. That is, we can add 12 10 times, so this will become 121. Now we can calculate the difference between them, right? We can calculate the difference between them. This will be the minimum, and we can pick the maximum. This is one way of doing it. Or else what we can do is we can perform modulo the larger the values, perform modulo of every value, so that we'll remove every multiple of 2 and bring this value so that they are on the same level. So everything, if we perform modulo, every 12 multiple will be gone, and it will reach to a point where the values lie between 1 and k, right? 1 and k minus 1, so 0 and k minus 1. So if we do that, uh, our array will look something like this when we perform modulo with k. That is 1, 2, 4, 120 is 12 power 10, so 12 into 10, so 8, 10 and 11, right? 8, 10 and 11. So if you're finding it difficult to understand this, assume that this is your initial array, and what you're simply doing is, since you can perform any number of operations, you are adding 12 10 times to this, so you get 131. Similarly, 12 10 times to it, you are getting 130. 12 10 times to this, you are getting 120. So instead of that, this can be our array, right? So first step, what we can simply do is, we can apply modulo over entire array and get these values. Okay, that is done. So first step, we'll apply modulo. We'll apply modulo with k so that all values are kind of in a level that is below 12, so that we can perform operation. Now this array is kind of sorted, but it would be, in other test cases where this might not be sorted, it would be better for us to sort, because what we have to do is we have to find max of array minus min of array, so it is better for us to sort the array. Now if you see, the answer is going to lie between these values, right? We have to find min of all these values. So first of all, what we can do is, by looking at this array, taking the values from this, our answer, we can say it as 11 minus 1, 10. Our answer is 10 for now. But if I add a value of k to this first element, in that case I'll get a new value, right? I'll get a new value, that is 13, and there is a possibility that this can give me the better answer than these two values, 1 and 11, better than 1 and 11. I can get a better answer here, so this can happen. But let's try to see what we'll get in this case. 1 and 11 is giving us 10, and if I add k, in this case what I'm going to get, 13 minus 2, 11. So it is not better, but so we'll try with other options. We don't know which two pairs will give you the shortest smallest one, so we'll just try with new pairs. So if I want 4 to be the minimum value in the two options, if I want 4 to be the minimum value, I should have a maximum, right? 2 is the minimum, so I can simply do 2 plus k, that is 14. So 14 minus 4, 10, right? So like this we can move forward. Next, if I want 8 as the minimum value, then I can add 4 plus k. So 4 plus k will give me 16, and the minimum value is 8. So 16 minus 8 will be 8. So best answer till now is 8. Now what if 10 is my minimum value? If 10 is going, if I want 10 to be my minimum value, I'll add plus k to this, the value of 8. So it will be 8 plus 12, so 20. 20 and 10 are the new minimum and maximum. So 20 minus 10 is 10. So we'll not update our answer. At last, 11 can be our minimum value, right? 11 can be our minimum value. Let's do one thing. Let's as read. 11 can be our minimum value if we want 11 to be our minimum value. Simple option is, we'll add k to the previous value, that is 10 plus k. So we are going to get the value of 22. So 22 minus 11, that is again equals to 11. So we'll, till now our answer is 8. Now we have next value as 13. But should we go there? If you see, we got 13 by adding k to the value of 1. And if we want it to be minimum, what we'll do, we'll simply add k to the value of 11. So it will be 11 plus 12, so 23. Again, aren't we repeating the same sequence? 13, 23 is same as 1 and 11, right? Both here we just added the value of k to it, k to both of them. So we'll be repeating the same values and again. So we will just stop it here. So like this, we will try every possibility. We'll try every possibility by keeping one value as the minimum. And if we keep that, what will be the maximum value? What will be the next least maximum value, so that difference will be smaller. So here, if you see, our array was like this, right? 1, 2, 4, 8, 10, and 11. Now I calculated the difference between 1 and 11. It came out to be 10. Now I want to move to keep 2 as minimum, right? I want to keep 2 as minimum. So here my best option to get the smallest differences, I need to make sure that from 2 the maximum value should be close as possible. That is, I can have two values. I can generate two values. That is, maybe I can generate multiple values, right? I can add k to this, I can add k to this, I can add k to this. But if I want the smallest difference, I need to add it to a smaller value, right? If I add k to a smaller value, let's say it is going to be somewhere here, or 13 is going to be somewhere here. But if I add k to any other value, like say 18, it will be here. So the difference is going to be smaller when we add k to the smaller value, right? So like this, we'll just check every pair and we'll find the optimal answer. So this is the main logic for this question, and let's try to implement it in code. Yeah, so let's try to implement this logic in code. So first we will start with the test cases. So we'll have a for loop which is running for t times. Then we have the values of n and k. So we'll take the input of it. Cool. Next we have our array. So we'll take the input of this array, list of, done. Now, as per our logic, we first what we'll try to is we'll try to generalize or like make them in the range of 1 to k by just applying mod with k. So for I in range of n, L of I will be equals to L of I modulo k. Okay, this will bring down every value uh, in the values of k. Okay, now we want this to be sorted so that we can directly pick the minimum and maximum, which are the first and last indices. So L of L dot sort. Now we'll declare a answer variable and we'll make sure the answer initially is nothing but the first element minus last element minus the first element in there. So L of n minus 1 minus L of 0 is our answer. Now what we are doing is we are adding the value of k to L of 0 and subtracting it with the L of 1 index, right? So we are need to gradually do that. So every time we add k to the recent element that we used, that is going to be the maximum, right? That is going to be the maximum every time. So instead of changing the values in our array, what we'll do is we'll we'll just declare one word m, which is going to tell us what is the maximum value that is going to present in the array. That is going to be nothing but the value of k plus the current element that we have used. So the maximum till now is L of 0 plus k. Now we'll do this for do the check for remaining values, that is the updating the answer part. So for I in range, since 0 is already done, we'll go from 1. No, answer will be equals to maximum of answer. Sorry, we need the minimum. So minimum of answer, comma, the current maximum value in the array minus the current minimum value, which is nothing but L of I itself. So answer equal to minimum of answer, comma, M minus L of I. We'll update our answer. But now for the next element, our value of M should be updated. So M will be equals to nothing but L of I plus K. So we'll repeat it until all values are completely done, and we'll have the smallest value in our answer variable. So we'll print our answer. So let's run this. Okay, our sample test cases are passing. Let's submit the solution. Yeah, so this is the answer for the clay closeness problem in the CodeChef Starters 131. Okay, let's start with the next question. And the next question given to us is called as encrypt value. Here we are given an array of size n, and initially we have a value s equals to 0, and for each item from 1 to n in any order, so any order you want, update the value of s by either adding a of I to s or multiplying a of I to s. That is the question. If you are able to do that, what is the maximum possible value of s that you can obtain? And it is also specified that since the output can be large, we need to use modulo here. Okay, next, coming to the examples, as you can see, we have these values, and what it is specified is since we can perform and multiplication and addition. First, he took the value of 2 and added it to us, and every time after that he added 2 to it, then this value is multiplied by 5 is multiplied by 4, giving us the maximum value of 8. So that is the example given to us. And for the next question, next example, that is 1 plus 1 plus 2, giving us 4, which is the maximum possible value. So these are the examples given to us. Now let's look at the question and try to understand how we can solve this optimally. So first thing is we have the value of s as 0. That means when in initial operation, it is guaranteed that if we multiply anything, the output will be 0 because s is initially 0. So the first operation we do is always going to be addition. The first operation that we need to do should always be addition. And next thing is we have two operations, right? We can add a value or multiply a value, and we can guarantee say that multiplication is going to give us a better answer most of the cases. In most of the cases, multiplication is going to give us a better answer than addition, right? So we would prefer multiplication most of the cases. The most of the cases are the only case where addition and multiplication give us the same answer is for 2 comma 2. If we add or we multiply, we get the same value of 4. But any value greater, if any value is greater than 2, one of the values is greater than 2, then 3 into 2 is 6, whereas 3 plus 2 is 5. So in any case, it is better for us to go with multiplication, because multiplication is of course going to give us a better answer. That is there. And addition is should be done for the first case. Now, are there any cases, if you think about it, are there any cases where even though one of the value is greater than 2, even though one of the value is greater than 2, we should prefer addition? So if you see, we have the value of 1, right? We have the value of 1, and by default, let's say we have 7 also. In this case, if we and we have, let's say, 10 also. In this case, if we go with normal way, so s will be equals to 1, s will be equals to 1, and next value is 7. So initially I'll add a value to this, and if I multiply, this value will be equal to 7, and if I multiply by 10, it will be 70. But this is not the optimal answer. So when we have 1 at any case, and let's say we have x as our current value of s into 1 is just going to give us s. But instead of that, when we have 1, if we do plus 1, it is going to give us the value of s plus 1, which we would prefer, right? So it is better for us when there is a 1, we'll go with addition. We'll go with addition. And this test case also shows us one more option, that is, when your s value is 1 and your array of I is greater than 1, in this case also it is better to go with s plus array of I, because this is going to give you a better value than multiplying it with 1. It doesn't matter where 1 is there. If our one of the multipliers is 1, it is go better to go with addition. Not only array of I, but the value of s, it can also be 1, right? So in both the cases, it is better for us to add 1. And for every other case, it is simple, we will just multiply. For every other case, it is just multiplying, because that will give you a better answer. Okay, now let's decide what should be how would we pick the value of s. Okay, now let's say we have this as an array 981. Okay, now if we just go with the same order as given. So initial value of s will be 9, then into 8, so we'll get the value of 72, and next one, so we'll do plus 1, so it will be 73. Now other way we can do this is 189. Okay, 1 plus 8, s is 1, next 1 plus 8 is 9, and we can multiply 9 with it, so again 81. As you can see, if we don't have ones, let's say if we don't have ones, let's say we just have 9 and 8, we can simply go with any value as our first number. It doesn't matter, we are just multiplying it. But when we have ones, it is better for us to keep the one in the first place, so that we can add it with other value, and we can multiply it. Multiply it. This would give us a better answer than adding one at the last instance. Adding one, adding all the ones at first and then multiplying with other values will give us a larger value compared to adding ones at the last. So this is one more case that we have to handle. For that, what we can do is we can just sort our array, and we'll handle those cases simply. Okay, so let's try to implement this logic in terms of code. Okay, so first we have t test cases, so we'll run a loop for t times. Next, we have the size of the array. So we'll just take the size of the array into the input. Next, we have the array given to us. So we'll take that also. Okay, next, so this is our input. So first, as we discussed, we have the value of s also. As we discussed just now, it is better for us to, bring up all the ones to the start and add those things other than adding those at the last. So what we can do is, we can just sort our list or array. So we'll sort it, and initial value of s will be s of, that is L of 0. The first value of L is going to be the initial value of S. Now we'll iterate for the remaining values for I in range 1 comma n, the remaining values in the array. Now if we discuss the condition, right, we discuss the condition, that is, if array of that is list of I equals to 1, if that is 1, or s of I is equals to 1, if even if one of the, sorry, not s of I, even if s is equals to 1, it is better for us to just add these things up, right? Just add these things up. So what we'll do is s plus equals to L of I, but for every other case we'll just multiply things. But the question also says that we can have a large value, right? So we have to apply modulo. So mod 1d9 plus 7, that is 10.9 plus 7, and we have to rewrite this. S will be equal to s plus L of I modulo mod variable. Okay, and we have to apply modulo. Similarly here to s equal to s into L of I, and we'll apply modulo here, and at last we'll print our answer, that is nothing but the value of s. Let's run this. So we passed our test cases. We'll submit this. Yeah, so the solution is accepted. So this was the encrypt value problem from lead code starters 130.